you, Shinu, can you pause the recording for a few minutes? Hello, Shinu.
Sir, done.
Okay. Acha, so just little bit. Let me talk to you a little bit. How many of you are really understanding what are the things being covered here? So, are you actually getting anything, or you have to work on that? You have to first thing is that are you conversant with all these kind of topics? First of all, that how this probabilistic machine learning, deep learning has come into picture.
This
Why
is
not same?
for
Why
first
not
time.
same? For the first time. Okay, and MLTL, how much conversant with how much conversant you people are, especially people from Greece. So
Actually, this
Greece,
is a new field for us. Actually, we are not doing any ML programming, and this is totally new learning
for
for
you
us.
people. Okay, okay. Acha, so another thing is that what is your batch profile, by the way? Means are all CSE, IT, this
Yes,
kind
yes.
of engineering or
All are CSC, computer science background,
computer
and
science?
many of them are familiar with Java programming. Mainly, the Chris
Okay,
are
okay.
doing Java based. Many of the my batchmates are Java programmer.
Okay, so I think that's why basically what I was thinking that you should means go through the foundations first. So
Yes.
foundational course on ML, DL as well as statistical modeling. Per se, statistics basically what is happening that in statistics there are lots of you can say all those concepts are coming in ML. Okay, almost. So if your statistics is clear, with foundation is clear or foundation is good, then I think it would be better for you to understand all these things, right?
Yes,
So
sir.
that's why I was thinking that why don't you actually take up this thing very seriously so that you can basically uplift your knowledge, okay, in this particular thing, MLDL. So okay, let me talk to GVL sir regarding this. Okay, so if possible then I can actually throw some courses on this so that you can actually learn this. Okay, so
Actually, the entire scope is too much, and in 5 days it is very tough to
yeah,
complete.
yeah. So that is
So I think about first a basic concept पता
hmm,
चीजें
hmm, hmm,
like ML and statistic first we should clear
hmm,
on it
hmm,
पता
hmm.
चीजें then go proceed.
I can understand. So that's why basically I was thinking that why should we start with stats and ML first, and then this not for this. This is already over, and actually this was I was thinking that for you can say the candidates are a little bit aware of this kind of machine learning concepts and all these things. I didn't think about these things right now before launching this. So okay. So let me think about this. So let me prepare a course outline if possible. Okay, then I'll try to forward. Okay, so then we can go for rigorous actually understanding of this, and basically foundations must be solid, okay, in this area. Okay, so okay, let's start. Acha,
Yes, sir.
Shinu, please start the recording. Okay, so what I stopped at, okay, so I was actually telling you that the classification problem, in classification problem basically what happens that you are comparing, you are actually proposing a model, okay, and you are when you are proposing that model will be predicting each of the observations, that whether they are truly whether they are properly classified or not. Okay, so let me just share my screen. Is it visible in full screen or in smaller one?
Yes, sir, visible in full screen.
Full screen. Okay. So here basically there are two types of problems in machine learning, by the way. Okay, so classification and so in case of supervised learning, okay, in case of supervised learning, so just to back to the basics, supervised learning framework. So here basically you are the learner is supervised, okay, in terms of mm, response predictor pair. Okay, so you are having a set of observations and which is having predictor set as well as response corresponding response value for that. Okay, now if response is continuous in nature, then that is called as regression problem. Regression problem. And response, if it is discrete in nature, discrete or categories in nature, that is known as classification problem. Okay, so this is what. So now in case of regression problems, the metrics, performance metrics are R square, RMSE, MAPE, etc. And they are not applicable to classification case. Okay, in classification, because in classification, uh, the response is category, okay, or discrete in nature. So in classification, response variable is discrete, okay, or categorical in nature. Okay, so that's why. So what are the performance metrics? Performance metrics are uh, performance metrics are ROC curve and AUC. Okay, so ROC curve and AUC. ROC means receiver operating characteristic. Operating characteristic curve, and AUC is area curve. So how this ROC curve and AUC, they are actually generated, okay, for a particular classifier. So suppose basically what happens that when you are having a data set like this, that let me take an example. Okay, so let me take a very simple example that uh, age of the patient is given and uh, test positive for a disease that is given. Okay, so suppose 20, age is 20, test positive, no. 25, no. 28, yes. Okay, then 30, no, then 35, no, then 38, yes, then 40, then yes, then 45, then suppose no, then 48, yes, then 40, 50, yes, like this it is going, right? So this is a kind of the response variable is whether you have to, what is the problem statement? Problem statement is build a predictive model to uh, predict whether a patient is positive without testing based on his or her age. Okay, so this is the problem statement, right? So basically, we will be writing that testing positive, okay, will be a function of age, right? Now here, if you have this kind of beta naught plus beta 1 into age, and that will be giving you test equals to positive, this will not work. This will not work. Okay, because because this particular functional relationship is good for continuous response, and as this response is positive, is only having values 0 and 1, so we need some, you can say, activation function or something called as link function. Okay, link function on beta naught plus beta 1 age, so that f of beta naught plus beta 1 age will be in 0 comma 1, will be in, or will be in 0 1 kind of values, right? Now how you can actually take that, it is not directly, it is not possible. So you are proposing something f of beta naught plus beta 1 age that will be in close interval 0 1, and that's why test positive will be coming as, okay, or it will be coming as probability of test positive equals to 1 given as given age. Okay, it will be given by 1 plus exponential of minus beta naught minus beta 1 into age. So this is actually called as logistic relation. Okay, now problem is how to measure the performance of the model or classifying, because we are classifying the patients into 0 or 1. Okay, so here we generally go by something called as uh, this one, that is called as ROC curve and AUC. But how this ROC curve is actually generated? So suppose this particular data is the original data, right? So this is the actual, right? And you are predicting using positive, predicting positive. Okay, so one is your actual, second is your predictive prediction positive. So this has come, suppose 0, then 0, then 0, then 0, then 1, then 1, then 1, then 1, then 1, then 1. Okay, so now, so here what happens, that I was telling about something called as confusion matrix. This confusion matrix is required to, this confusion is matrix is required to build up the ROC curve. Okay, and uh, different measures. Okay, so confusion matrix is having one side, it is actual response, like whether it is positive or negative, and on the other side it is again predicted, positive or negative, but that is predicted. So you can see here that actually testing positive 0 0 1 0 0 1 1 0 1 1. Okay, so these are actual. On the second column, third column, it is the predicted positive. That means 0 0 0 0, then 1 1 1 1 1. Okay, now here what is happening, that I'm comparing this actual test positive and the predicted test positive. Okay, so the first one, that is actually negative, predicted also negative. Second one, actual negative, predicted negative. Third one is actual positive but predicted negative. Okay, so then it is 0 0 means actual negative, predicted also negative. In this way it is coming. Now when actually it is positive and predicted also positive, then it is called as true positive. When actually negative and predicted also negative, then it is called as true negative. Then if it is actually positive but predicted as negative, then it will be called as false negative. And actually it is negative but predicted as positive, then we'll be calling it as false positive. Okay, so these are the you can say the different metrics that will be used for calculating or producing this ROC curve. Now, what are the metrics that are actually required or evolved metrics out of this? Okay, so here we'll be telling that first one is several accuracy measures actually. So first one is called as sensitivity or recall. This is also called as TPR. Okay, so TPR is given by TP by TP plus FM. So go to the this thing. So TPR equals to true positive rate. Okay, true positive rate. Now true positive rate is telling about the actual positive row. Okay, so actually positive row, on that row I am looking at. Okay, so this will be giving us the true positive rate. So true positive rate will be true positive divided by true positive plus false negative. And they are on the actual positive row. Okay. Achha, next is called as sensitivity. Sensitivity, sensitivity, sensitivity. It is known as true negative rate. Okay, so true negative rate, it is coming as true negative by true negative plus false positive. Now, true negative is basically at the actual negative row. So TNR is Tn divided by Tn plus Ft. Always remember this. Okay, so these are the two. Third one is precision. So precision is TP by TP TP by TP plus FP. Okay, so precision is TP by TP plus FP. Okay, so precision, you can find out that TP by TP plus FP. So it is telling you, precision is telling you that about the predicted positive column, a predicted positive, TP by TP plus FP. Now the last one is called as F1 score, F score, sorry. F score is given by 2 into recall multiplied by precision by recall plus precision. Okay, so recall 2 into recall multiplied by precision divided by recall plus precision. Is it okay? So these are the different measures that are coming from this particular confusion matrix. Right now, what is happening? There are some more measures you can calculate. Okay, so now plot the 1 minus specificity chart. This is specificity. TNR is specificity. TNR is specificity. 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 Specific. Specificity. Okay. Now 1 minus specificity is FPR, false positive rate. So 1 minus specificity, if I do 1 minus Tn by Tn plus Fp equals to Tn cancel. This will be Fp by Tn plus Fp. Okay. So Fp by Tn plus Fp will be actually negative rho, but here the numerator is Fp. This is known as, so this is known as false positive rate. Okay, so false positive rate. So plot the false positive rate versus true positive rate. Okay, false positive rate versus true positive rate, uh, and for different threshold. For different thresholds of prediction of classes. Okay, now what is this thresholds of prediction of classes? I am coming to that. Prediction of classes. Okay, so and join the dots. You'll be getting something called as ROC curve. Okay, and steeper the curve, better the steeper the curve, better the classifier. Now, how actually this is developed? Okay, so let us just do one thing, do little experiment. So suppose I am telling that uh, I am telling that here actually what happens, that I am finding out probability of test positive. This is probability of, okay, equals to 1 given age. So this is a continuous value, right? So it can be 0.2, 0.3, 0.1, 0.15 like this. It will be coming. So if you suppose write this, okay. So suppose predicted probability of class 1 given x. Okay. So this is suppose 0.1, 0.15, 0.18. Okay. Then 0.21, then 0.3, then 0.35, then 0.45, then 0.48, 58, then suppose 78, then suppose 1. In this way, you have got. These are the predicted probabilities. Predicted probabilities of test is positive. Now suppose where to set the cutoff. Okay. So generally what happens that we tell a rule like this. Yes, please. Anybody is asking anything? Please, until you ask anything, na. So I'll not be understanding that exactly where I should contribute. Means what should be the rigor and all these things. So please tell me. Okay, so here what is happening that so suppose cutoff. So what is this cutoff, by the way? So cutoff, I am telling that if pi of 1 given x is more than 0.5, then it is a positive class. Okay, so this is 1. Then second is if pi of 1 given x is greater than 0.35, then it is 1. Then C is pi is suppose 1 given x is greater than 0.3, then it is 1. So what will happen that suppose for this 0.5, so 0.5, then 0.35, and then 0.3. Okay, these three. So now if you look at 0.5, so more than 0.5, that will be 1. So these three are 1 and they all are zeros. Okay. Now 0.35 you will see. Then till this one. Okay, so this one also be 1. So 1, 1, 1, 1. And rest all will be zeros. Then 0.3. So 0.3 will be this much. So I'm taking greater than equals to. Okay, so greater than equals to. So 0.3. So this much. So here also this one. So this one, this one, this one, this one. 0, 0, 0, 0. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay. Now the thing is that these are all predicted. These are all predicted. So in this case, the first case, 0.5, how many are true positive and how many are true negative? I have to find out. So 1, 2, then 3, then 4, then so 4 are true negative. Okay. How many are true positive? 2 are true positive for 0.5. Okay, so in this way, can you find out the confusion matrix for all these three? Okay, so all these three, after finding out the confusion matrices, then you go for finding out what is the FPR and TPR. Then you find out what are the FPR and TPR. Now that FPR and TPR, you are actually plotting, you are actually selecting on this particular graph. So this side is FPR, this side is TPR. This side is TPR. So suppose FPR and TPR somewhere here, somewhere, then here, then here, then suppose here, then suppose here, then here. Okay. So now if you, so these are actually based on the threshold you have set. This one, then 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 this one. Now this is quite steep. Okay. So this is not flat. Now the thing is that if your classifier is not at all good, okay, so generally it will be uh, uh, kind of a 45-degree line. Okay, so 45-degree line means that this TPR and FPR, they are basically uh, both are changing in the same rate. Okay, both are changing in the same rate, right? So now next is that when TPR, so when you are getting this particular curve as a 45-degree line, that means your classifier, you should leave that classifier. Okay, don't go for that particular classifier model. Okay, it is not at all doing anything good. So it is kind of 50-50 chance of positive and negative. Okay, so leave that, just scrap that model. Okay, so in this way, basically, we do this classification performance analysis. Is it okay? Anybody is having any kind of doubt, please tell me. Now this is same across all kind of MLDL model. Okay, so your model can be logistic regression, your model can be decision tree, your model can be anything else. Your model can be neural network. Okay, but the thing is that performance evaluation is same for all. Okay, performance evaluation is same for all. So please note it down. I think this will help you in understanding these classifiers. Is it okay? Now let me go to just implementation of that neural networks. Okay, using in Python. Okay, just for a minute. Okay, so I was showing you that implementing neural network from scratch, where we are generating a synthetic data, and this is for classification purpose. So for classification purpose, is it okay? Is it okay? So can I start? Can I start? Okay, so let me just import the packages first. Then we'll be using a dataset that is created by sklearn.datasets. This is known as make moons. Okay, so you can find out that we cannot have a line. Okay, we cannot have a line like this. It is not possible. Okay, so we should have plane or something like plane or line. Sorry, how to use it? Scratch. For the scratch, I'm not getting. From scratch, I am telling that I am using only numpy. Okay, so it is from scratch means it is only using numpy. Okay, understanding? Yes, please come. Just 1 second. Okay, so we are uh, from scratch means we are actually using only numpy. Okay, numpy means all the basic things basically we can get. Okay, and we are trying to develop that logic. Otherwise, if you start using PyTorch from the day one, then actually that logical understanding will not be good. Okay,
So on before this we have already used the library numpy. उसमें scratch जैसा word का use नहीं हुआ
No,
था.
no, no.
अभी
Scratch means I am telling that you are starting from the beginning. Okay, so it is basically starting from the beginning, starting from scratch. Starting from scratch. Okay, so here what is happening that here what is happening that we are actually we are using only the numpy. Okay, we are not using any kind of hi-fi, you can say. We are not using any kind of hi-fi packages. Just 1 second. Okay, just I am having an urgent call. Yes. So we'll be using that particular idea of this feed forward network, feed forward operation, and the back propagation operation. Okay. So feed forward means how these particular inputs, how these inputs are getting accumulated, how the sum product of the weights and the inputs they are getting calculated, and they are passed through the activation function, and they are passed through the activation function, and basically how this prediction is being done, and then you are back propagating the error. Okay, you are back propagating the error and trying to modify the weight. Okay, so that is basically that is the objective of this particular program. Okay, so I have created this data that is known as make moons data. Okay, you can see that these are kind of non-linearly distributed. Okay, now first we are going for logistic regression. Okay, first we are going for logistic regression. So logistic regression, basically here what will happen that logistic regression that will be behaving very poorly. Okay, so that basically we are starting with this base model and we are trying to find out, okay, how it is behaving. Now you can see that logistic regression, you can see, so my data points were these red points are on this side, and on this side it is the blue points. Is it okay? Now as it is a linear boundary, okay, as it is a linear boundary, so you can see that it is not its performance is not that good. Okay, you'll be finding that true positive, true negative kind of sorry, false positive and false negative kind of things much more than expected. Okay, so this is why linear boundary will not be performing better in this particular scenario. Okay, it will not be a good performing model in this particular scenario. So we are going for neural network. Now in neural network, you can see that as I was discussing that here I didn't introduce any kind of bias node. Okay, I didn't introduce any kind of bias node here. So here two input nodes are there because we are having two dimensional data set. Okay, and in the input layer it is two dimensions, that is two variables. In hidden layer there are five nodes, and in the output layer there are also why two outputs are there, two output nodes are there. So one will be for 0 class, another will be for 1 class. Okay, so here what we can actually do that we can
आज को सिर्फ कर दो आज को ना शिफ्ट कर दे उसको
so here so let us just look at the equations. Okay, let us just look at the equations. First is that your input is x, right? And then W1 is the weights from connections from the input layer to the hidden layer. Okay, plus the bias node input. Okay, so that is the input. Yeah, by two output nodes. Okay, two output nodes means two classes, because here you can see one is a red class and another is a blue class. Okay, so this is actually, this is having base is something called as encoding. Okay, data encoding. So let me just talk to you regarding that first. Let me just get it clarified. So what's that? The option. What is that screen share? Where is the screen share?
Then sir, for two output we require two activation functions, because वहां
No,
से
no.
भी में एक ही एक्टिवेशन में जाके सारे सबमिट हो रहे थे। यहाँ
हाँ
दो
हाँ हाँ
एक्टिवेशन है तो फिर यहाँ दो आउटपुट दो एक्टिवेशन होनी चाहिए ना फिर तो।
हाँ हाँ हाँ, coming to that, coming to that. So so here is the shared screen. Stop. Okay. ठीक है. So here what is happening? So let me just draw it here. So there is something called as uh, variable encoding. Okay, so variable encoding. This is especially important for the discrete or categorical variables. Okay. So now what happens that suppose I'm telling that take the example of this only, that predicted positive. So predicted positive, suppose I'm telling, and I'm basically taking this one, okay, 0, 1, 0, 0, 1, 0, 0, 0, 1, like this. Okay, so now we have, what we do, we encode them with dummy variables. Encode with dummy variables. Okay, so we call it as that if it is positive, then it is 1, and if it is negative, then it is 0. So as it is negative for the first one, so this will be 0, 1. As it is positive for the second one, so this will be 1, 0. Okay, this will be 0. That's why this will be 0, 1. Okay, 0 means 0, 1. Then 1 means 1, 0. So like this, it is going. Are you understanding this one? This is called as one hot encoding. And in case of deep learning, this one hot encoding actually works. We actually work for this particular one hot encoding. Okay, we encode the variables using one hot encoding. One hot means that the value it is showing. So suppose let us take, instead of 0, 1, let us take suppose 1, 2, 3. Okay, so 1, then 2, then 1, then 3, then 3, then 2, then 1, then 1, then 2, then 3. Okay, so for that, one hot encoding will be having 3 columns, 1, 2, and 3. First one is 1, so this will be 1, 0, 0. Second one is 2, so this will be 0, 1, 0. Third one is 1, so this is 1, 0, 0. 3 is 0, 0, 1. Then 3 is 0, 0, 1. Then 2 is 0, 1, 0. 1 is 0, 1, sorry, this will be 1, 0, 0. This will be 1, 0, 0. Then this will be 1, 0, 0. Then this will be 2, 2 is 0, 1, 0. Then this will be 3 will be 0, 0, 1. Right. So in this way, in our case, okay, so in our case, we are having 2 output nodes. Okay, so 2 output nodes we are having. Now the thing is that the predicted output, yeah, so the predicted one actually. So predicted one, if it is towards 0, then that particular node will be having predicted value much higher than the other one. Okay, so if you look at this one, if you look at this one, Where is it? Okay, so here what is happening that your neural network is having total 2 output nodes. Okay, so output node. Now what will happen that by that uh, feed forward mechanism, you are actually predicting the value of a particular input combination. That is the input row, right? Now the thing is, if it is towards the 0 class, then this output 1, so output 1 is suppose 0 plus and output 2 is suppose 1 plus. So output 1 will be having higher output, okay, and output 2 will be having lower value of prediction. Okay, so this is how basically that is modeled. Okay, now we can go for this particular binary cross entropy loss. Okay, so we can actually look at this particular code, then we can find out exactly what is happening. So we are using at the final layer, we are using the activation function as softmax. Softmax is e to the power whatever be the predicted value for that node divided by e to the sum of e to the power all of the predicted values. Okay, so it is basically kind of softmax is coming like softmax is coming like so softmax is actually so suppose node 1 output node 1, okay, it is having value as 0.35, okay, and output node 2 is having as suppose 0.75. Suppose they are not bound to be sum to 1. Okay, so it's not like that. Okay, it is not normalized. It might happen, but we are normalizing it using softmax. So we are passing it through softmax. Okay, so softmax of 0.35. How we will be calculating? It will be e to the power 0.35 divided by e to the power 0.35 plus e to the power 0.75. So in this way, basically, it is done. Softmax of 0.75, softmax of 0.75, the other node, it is be e to the power 0.75 divided by e to the power 0.35 plus e to the power 0.75. So this is normalized,
Screen, screen
right?
is
Getting
not
my
shared.
point?
The screen is not shared.
The screen is not shared. Array, should have told it earlier. Okay, sorry. But it is shared as a node, not shared. Okay, so output node 1 has got predicted value as 0.35. And it does not mean that only 0.35, 0.75 like this it will be coming. It can be suppose 5 has come. Okay, but as you have used suppose sigmoid function, then most probably the output will be coming between 0 and 1. Okay, so it is, so it can be suppose 5, this can be 7. Okay, this can happen, no issues. Okay, so it is softmax 5 and softmax 7. So softmax 5 will be e to the power 5 divided by e to the power 5 plus e to the power 7. Like that it will become. Okay, so here this, let me go back to this. Okay, understood? Understood? So this is why 2 nodes are given and this is one hot encoding. Is it okay or not? Is it okay or not? Please respond, Mr. Amar. Okay.
सर ये सॉफ्ट मैक्स क्या मतलब ये यू हैव यूज एज एक्टिवेशन फंक्शन है क्या सॉफ्ट मैक्स?
Yeah, at the final layer. It is
Okay.
also kind of activation function, but that is used only for final layer, not and for classification only. Okay,
Yeah,
not for any other case.
why you have used this function, not tan sigmoidal or sigmoidal or
No,
any
basically
other
what
functions,
happens?
non-linear
Okay.
natures?
Softmax nature is it is a kind of normalization. Okay, it is a kind of normalization I'm doing.
तो फिर for normalization functions we should also normalize our data. Data
No, no,
precursor से
no,
भी
no, no.
normalize करना
That
पड़ेगा.
no, 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 no. That is not required. Neural network is very much, you can say, robust regarding the input data. So this you require for linear regression might be, or logistic regression you might be. Okay, neural network, whatever you give, whatever data you will be giving, okay, it will be starting working on that, and it will be giving you good result. That is the good thing with neural networks, because it is highly non-parametric in nature. Getting my point? It is highly non-parametric in nature. Highly non-parametric.
Means
Yesterday I was
means you have used this function for the purpose of normalization, so the data comes in a normalized form. I think
हाँ
वो 0 से 1 के बीच में लाने के लिए है क्या ये सब?
exactly zero के 1 0 and 1 के बीच में only नहीं, you have to basically total you will be having one total. So two classes probability you are calculating. Okay, so two classes probability you are calculating. So class 1, if it is suppose 0.45, then class 2 must be 0.55. Getting my point? So
Okay.
sigmoid function is mainly used for making the output, or you can say between 0 and 1. So instead of two nodes, you could have used one node only. Instead of two nodes at the output layer, you could have used one node only. And that time you have to use sigmoid function. That time softmax will not work, because softmax is for one hot encoding. And if you are keeping for binary classification, if you are keeping only one node at the output, then it is not one hot encoding. It is called as dummy variable encoding. Sorry, it is, yeah, it is.
Means what we concluded that if we have uses sigmoid function, then in that case we have used two activation function to
No, 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 no.
avoid.
No. Just you are just telling opposite. If you are using sigmoid, then instead of two nodes, you will be using one node.
No, but I have taken out two output na. For getting the two output, we have to use two sigmoid function. If you
No,
not using this one.
no. Two sigmoid function, then it will be, both will be giving, suppose value, one will be giving 0.35 and another will be giving 0.85. So total will be more than one. Getting my point?
Okay, good.
Getting my point? So that is the problem. Okay, softmax is doing both of these things as activation function, as well as it is normalizing. Okay, and finally, another thing I should tell, that had it been linear regression, we would not use any kind of activation function in the final layer, and that will be having only one node if it is a multiple linear regression kind of, means one response variable, one node. It is not kind of that it does not depend upon values. Okay, here it is classification, it is dependent upon values, that how many values the classifier is having the response, whether it is binary classification or ternary or tertiary. Okay, what kind of classification it is. Okay, based on that. Okay, so now come to this. So the governing equation is Z1 means the input to the next layer, next hidden layer will be input layer inputs multiplied by the weights plus the bias node. Okay, then the activation function I am using tan h. Okay, so I am passing this input to the hidden layer nodes through a tan h, and that is the output of that layer, which is acting as input to the next layer. Then Z2 is the input to the next layer. Okay, means you are having some product of weight and the outputs of the earlier layer plus bias. Then the output of the output layer, the next layer, that is coming as y hat, and that is softmax of Z2. Okay, so this is how it is coming. Next is, yes. So what are the update equation, weight update equation? So weight update equation. Now here you have used tan h in case of this thing in the input layer to hidden layer. So its derivative will be 1 minus tan h square. So you can actually do it by your own. That sigmoid, it is sigmoid multiplied by 1 minus sigmoid. But for tan h, it is tan h, 1 minus tan h square, I think. You can please check that. Is it okay? Now, some pre-processing and allocating some initialization. Now, how to find out the total loss? How to find out the total loss? So total loss basically incoming is that softmax function you are using. So that's for that particular softmax function we are using this particular function, calculate loss. Now feed forward, we are doing this predict function. Okay, so for feed forward we are doing this predict function. So you can just check that this is very simple equation. You don't need any Fourier series or Laplace transform for this. All these things, no differential equation also. Only product and summation. But that's all. Now after that we are building the model.
So predict function का क्या use है इसमें? क्या predict
Predict
करा?
function. What is happening? That forward propagation, that is the feed forward one. So Z1. So we are actually using that particular these functions here. So Z1 is NP dot product of W1 multiplied by X plus B1. Okay, you can check it.
So all
X,
the mathematics that has been expressed, that comes under the predict function.
yeah, exactly. Okay, so in this way, predict, then we are building the model, right? And building the model, we are doing the back propagation itself, here itself. Okay, so back propagation, you can see little bit complex kind of looking, but it is very easy. It is very easy actually. Then so now I am actually using 3 layers. So we are making that program generic enough to go for any number of layers. Okay. Is it any number of layers or number of layers? Let me check. Number of passes, hidden dimension. Hidden dimension. Yes, we are doing that. Okay. Now next is, let me run the. Okay. So this is 3 layer. Now, if you are basically using different number of layers, so first is one different number of hidden layers. First is one hidden layer, second is two different hidden layer, third is 3, then 4, then 5, then 20, then 50. Okay, for all of this, we are actually trying to build up our neural network model, and we are trying to find out exactly how it is looking. So if it is only one layer, then it is same as the logistic regression. You can check. If it is having 2 hidden layers, then you can see little bit curvature it has got. Okay, so let me run it here. Okay, so this one, hidden layer 3, number of hidden layer 3. Okay, so then number of hidden layer 4, number of hidden layer 5, then hidden layer 20, then 50. Okay, so as you'll be, means it is kind of more the sugar, more you'll be getting sweetened. Okay, so if you are increasing the number of hidden layers, you'll be getting more and more accuracy regarding the training of the data set. But it might not guarantee that it will not be overfitting. Okay, so there is a huge chance that it might overfit. Okay, so next is you can do some exercises are given here. Okay, so you can do this later. I'll be sharing this code with you. Just play with it. Okay, change the
one more thing is that in hidden layer number of neurons भी तो selection होता है. How many neurons in each and every hidden layers?
that is actually kept as 5, I think. That is kept as 5, I think. Let me check. In each hidden layer, how many nodes are there, right? You are asking.
Right.
I think it has been kept as 5. I think. Number of I have to find it out. Number of passes, number of. Acha, it is I think generated n input dimension, h dimension. Okay. Acha, 1 minute. It is not the layer. Sorry. It is not the layers. It is the number of nodes in that hidden layer. I'm extremely sorry. It is basically size of that hidden layer. Okay, it is the size of the hidden layer, means the number of nodes in that particular hidden layer. Hidden layer is 1 only. Okay, but what you can do that you can actually increase the number of hidden layers also. Okay, you can use the
number of neurons. Node with one layer.
Exactly, number of nodes. Number of nodes means the neurons. Yes.
Okay. But so you are using only one hidden layer here.
Yeah, only one hidden layer, but changing the number of nodes. Okay, in
that's
why
I was thinking number of hidden layers are बढ़ा रहे हैं.
नहीं, number of hidden layer बढ़ाने से भी you will be getting much accuracy. Okay, training accuracy.
This is the tuning thing. How
How
much hidden layer, how much nodes in between two, you have to tune this.
Yes. So there might be so all this basically code you can actually put it in a pipeline and you can run for different sets of parameters. This is a kind of hyperparameter tuning in deep learning. This is called as hyperparameter tuning in the deep learning. Yeah. Okay, so this one. Next is, let me show you something related to image processing. Okay, so image processing, I'll share this file also. This also I'll be sharing with you. So I have already downloaded the data, MNIST data. Okay, that is digits data, right? So handwritten one. So let me run this. Here the governing equations are given. Here many of the cases you are using a ReLU function because ReLU is easy to handle. How the parameters are getting updated, how these matrices are coming, means how the matrices, what are the orders of the matrices. Okay, in that way. Then so we are using simple gradient descent. Okay, you can actually check. So we are getting around 85% accuracy on the training set. It has not completed yet. It is running. Yeah, around 85%. That is coming as 0.846, right? So let us do little predictions. Okay, so first one is 0, right? And its level is 0. Okay. Then second one is 3 and 3, then 8 and 8, then 9 and 9. So you can actually go a little longer on, you can say, testing that whether your model is performing correctly or not. Okay. So you can play with this particular program. Next is, let me show you regarding this particular PyTorch. So in PyTorch, basically,
sir, I will interrupt you. In
yes.
image processing, image is data is taken to be for gray level 0 to 255. So it is two-dimensional data.
Two-dimensional data. Yes.
Data. How a two-dimensional data means that can be taken as in form of X input.
Okay,
X.
so you don't know this one.
Two-dimensional data in X and Y form. So I think
okay.
इसको linearly feed up a second for that.
Okay. Let me come to that. So basically, for image processing, we are having we are having dedicated kind of neural networks. Those are known as CNN, convolutional neural network. Okay, convolutional neural network. But you can implement it as a simple multi-layer perceptron also instead of going into convolutional one. Okay, so Acha, you don't. Okay, okay. So these are very nice things to know. Very interesting. Okay, so basically, what is happening that your image is suppose 256 by 256. So this side 256, this side 256. These are all pixel levels, right? On the in the squares, they are all pixel levels, right?
These are the pixels here, and suppose it is gray color image or black and white. नहीं suppose
हाँ,
gray gray color है. It is gray
हाँ,
color से
if
0
it
to
is
255 में
color, then
equivariance होगा.
हाँ, so
Their
if it is
intensity is 0 to 2. It is not binary. It is
yeah,
gray, so the gray label is 0 to 255. तो उसके different values आएंगे. अब सारी
okay.
values पे feed करने हैं. फिर
Exactly.
normalization
So
कैसे
now
होगा?
normalization is required. So you'll be bringing all into 0 and 1. Okay. Now the thing is that if it is suppose colored image, then it will be RGB. So 3 channels will be there.
Color, I'm not going in that deep layer.
Okay. So only gray.
मुझे color नहीं
Okay.
चाहिए. मुझे
So
gray में चाहिए. ग्रे में
you
आप डेटा कैसे मतलब कैसे प्रिपेयर कर रहे हो ये मुझे चाहिए बस.
so this is basically first you have to standardize. So from 0 to 255, you are making it into 0 to 1. Okay. So divide everything by 255. All
नहीं
the
सर वो तो नॉर्मलाइजेशन कर देंगे सब तक करके
normalization हो जाएगा.
वो कर
Now the
देंगे.
thing is,
Not
yeah, coming to that. Now the thing is that what you are doing, that you are making it as a vector. What is that vector? This is suppose first column, second column, third column, fourth column, fifth column, sixth column, seventh column. Okay. So this is the first column. Then you are concatenating it, second column, then third column, then fourth column, like this here. Okay. So this will become
this is
250.
making it column wise or row wise. It is very
No,
confusing.
column wise. You can make it row wise also, but generally we go for column wise. You can make it because what will happen that you have to maintain this thing for all of the data points.
इसे कॉलम में जितने भी आए नॉर्मलाइज करके प्लस
Exactly.
सेकंड में जितने आए वो नॉर्मलाइज
हाँ.
प्लस ये सारे
हाँ,
डेटा
तो
सेट रेडी हो गए. तो हमारा
concatenation you have
इनपुट
to.
तो ये सारे जोड़ करके तुम्हारा इनपुट सिर्फ
हाँ.
एक ही हुआ. मतलब x is here not x1 x2, here is only x.
हाँ, only
for,
X, only
for,
single
for,
input,
for,
single input.
for one image.
No. Sorry. Come, let me come to that. These are basically all these gray scales. Okay, gray values. They are one input. Okay, they are all one input like this. It is going. This is one observation, one row. This is one row. Okay, so one observation.
हाँ लेकिन बट दिस इज ओनली फॉर अ स्मॉल एक किसी एक इमेज के लिए सारा समअप हो गया.
हाँ, so this is one image.
को अगर 2 इमेज पे 3 इमेज को ट्रेनिंग के लिए भेजना है तो
No. तो उसीलिए तो the problem is MLP is not good for MLP framework is not good for image processing. So what you have to do, you have to actually go for convolutional neural network. So for images, we prefer convolutional neural network. But there also you need to do this kind of concatenation of the columns, but much later. Okay, convolutional neural network. So convolutional neural networks, basically this convolution actually comes into picture. So what happens that we take some filters. Okay, filters. Suppose 3 by 3. So 3 by 3 now will be convolving. Okay. So what will happen that this image 256 by 256 that will be coming in a smaller size, isn't it? Can you please confirm? So then again some convolution, then again some convolution, then again you might have this kind of summing up. What is that called as filtering? Along with filtering, you are basically taking maximum of this
वो
particular.
मास्किंग हो गया मतलब क्या बोलते हैं.
No, masking nahi. That is called as, I'm forgetting its name. One is padding is there. Suppose if you want border in that image, so that is basically zero padding you require. Sum is called as okay. Suppose I am having 3 by 3. Okay, 3 by 3, one matrix I have got. So whatever the maximum value, I'll be taking. Oh, max pooling. So this is called as pooling. Max pooling, average pooling, many kind of poolings are there. Max, average, many kind of poolings are there. So then what will happen? Then you might be getting, suppose 20 by 20. Okay, so from 256 by 256, now you have come to 20 by 20. Again you do, okay, convolution. Then you might get, suppose 10 by 10. So this has now come to, suppose 10 by 10. Then you take the columns and concatenate the columns. Okay. Then this is, suppose this actual output is suppose 7. So next, that's output is suppose 8. Next, it is output is suppose 1. So now you are inputting this as, so this is having 100 elements. So 100 input variables will be there, each containing the modified gray level in terms of convolution, pooling, padding, many kind of operations that can be possible. Okay, and based on that, basically this now you go for MLP framework. Now you go for MLP framework. Is it okay? This is how.
Let us come first case. वो तो अपने convolution की तरफ चले गए, ठीक है. Multiple images के लिए we go for the CNN, right? For the simple अभी जो चला था जिसमें सारे आपने concate कर दिया, normalize कर लिया. इस normalization के लिए फिर आपने process किया feed forward, then activation function choose कर लिया. Output पर भी ऐसे
now output layer में
आपने फिर back propagation कर लिया. ये करते ही जब तक
wait
जो आ गया. लेकिन सर ये करने के बाद में जो आया अभी उसको वापस उस इमेज को कैसे रिफॉर्म करोगे आप? ये
so basically उसको back we can actually find out this image form of that particularly we are now picking up that what input it was, which input it was taken. Okay, so this is 0th node, this is 1, then 2, like this it will be going up to 9. So total 10 output nodes will be there. You will be using softmax function. Now whichever node will be having the highest value, that will be given as the class of predicted class. Okay, getting my point? Now in predicted class, here what will happen, that confusion matrix will be created. Confusion matrix. Okay, now it will no more be 2 by 2, it will be 10 by 10. Okay, so it will be 10 by 10. So 0, 1, 2, 3, 4, 5, 6, up to 9. Right? Here also 0, 1, 2, 3, up to 9. Now, how many are 0? How many zeros are actual? Okay, so how many zeros are actually 0? How many zeros are shown as 1? Okay, how many zeros are predicted as 2? Like this, it will be going. So based on this, you'll be finding a measure. Okay, based on this, you'll be finding some measures that what are the this accuracy and what is the precision. Okay, so I'm not going into that performance metrics and all these things because our aim was to look into the mathematics of this modeling. Okay, so that's why we didn't look much into or we didn't include much of this particular performance indicators of this particular models. Okay, so here what is happening, that first you are
my question is Jinesh, ये करने के बाद भी इमेज ये नॉर्मलाइज करने के बाद में आउटपुट पे जब आए तो भी नॉर्मलाइज वैल्यू आएगी ना फिर.
हाँ, but which input it is coming from? So but which input it is coming from, we can have track na, that which input it is coming from, which input image is feeded in the network to get that output. I can find out that. So here what is happening, here prediction mein what is happening, that I am actually giving a set of images. Okay, so suppose I am giving 100th image. Okay, so 100th image, so that is actually that image is actually 8. image of an 8. Okay, image of an 8, and its level is also 8. Okay, suppose I am giving the 1000 image. So now see that its prediction is 4, but uska actually number hai 9. Is it okay now? This is misclassification. Are you getting my point, sir?
Yes.
So basically what is happening, we are matching with the actual level and the predicted. And that input I am tracking, that which input it is. And I am basically taking that image. That actually in this thing, na, in IM show, there is a function, IM show, image show. Okay, so where is that? Let me just find it out. Predict IM show. Where is that predict function? Test prediction. Yes. Current image. Acha, here the image is basically fetched from the dataset only. So no, they are not converting it. Okay. Acha, regarding the actual processing of that, so here convolutional neural network has not been used. CNN has not been used, but we can use that. I have actually kept it outside of this course. Acha, next is, so is it okay? Do you have doubts? Do you have doubts still, sir? Mr. Amar? So can I proceed?
In this case, it is okay, sir. In this case, it is okay. But
For
any suppose a case a image denoising a case is there for any image, if you want to denoising it. So in that case, image is taken and image is pre-processed through normalization. Then
that is a long process.
That is long process.
process.
The last then post processing.
So see, just like whenever we start cooking something, na, so we spend most of the time on, or you can say most of the devoted time or allocated time in the preparation itself. सब्जी काटना, मसाला ये करना, ठीक है ना, सब कुछ prepare करके, then how much time does it take for cooking, actual cooking? So the final, that MLP, multi-layer perceptron, is the cooking, and the pre-processing is basically consuming too much time. And many a time you'll be basically stuck with the computational power, because images are so huge data set. Okay, so here MNIST, I have taken smaller data set. You can say portion of that. So if you look at the larger data set now, you'll not be able to run, because one of my students, she was actually working on.
Sir, ठीक है. I'm asking the question out of आपके syllabus है. My question is that confusion is that कि आपने सारी images को एक ही कॉलम या रो में एक ही साथ में ऐड अप कर लिया, फिर बाद में पोस्ट प्रोसेसिंग में चलिए डीनॉर्मलाइजेशन कर लिया, फिर वापस जब वो इमेज को वापस सबको सम अप करना होगा तो फिर वो किस सीक्वेंस में आएगा?
See, you are actually keeping the track of which image it is.
नहीं, आप फर्स्ट जो आपने एक इमेज लिया, उस एक ही इमेज बारे बात करते हैं, नॉट टॉकिंग अबाउट मेनी इमेजेस, आई एम नॉट गोइंग फॉर कन्वोल्यूशन, कुछ नहीं करना.
So let me open the slides.
ओनली मुझे मेथोडोलॉजी समझना था कि आपने पहले बोला कि इसको एक साथ में करेंगे, ऐड अप करेंगे कॉलम वाइज या रो वाइज, व्हाटएवर सिलेक्शन इज देयर. तो
so basically
प्रोसेस करने के बाद जब लास्ट में जनरेट करेंगे उसको फिर किस सीक्वेंस में ऐड करेंगे, सो दैट कि हमें इमेज दिख जाए, क्योंकि हमें भी 2 डायमेंशनल चले, फिर 1 डायमेंशनल गए, फिर
so you are already
ऐड करेंगे.
So you are already having the image repository with you. Okay, it is not getting disturbed. You are pre-processing means you are taking image from that, you are processing, and you are passing through the neural network. Getting my point? So image 1, so let me just tell you. So image 1 is suppose of 0. image 2, it is suppose of 9. Image 3, it is suppose of image 5. Okay. Image 4, it is suppose of image 6. Okay. Then image 5, it is suppose of image 7. So these 5 images I am taking. Okay. So I am not going into convolutional. So this is 255, 256 by 256. This is also 256 by 256, all images. So now you have taken out the columns. Okay, you have taken out the columns, and these squares are having pixel values, right? So now 256 by 256. So what is 256 multiplied by 256? What is the value? By the way, what is the value?
65536.
256 multiplied by 256. Okay.
65536.
65536. Okay. So this is 65536 elements. This is the first data point. Okay. This is 655536. This is also 65536. This is also 65536. This is also 65536. Okay. Now this is actual label is suppose 0, this is suppose 4, this is suppose 6, this is suppose 5, and this is suppose 9. Got my point? Okay. Now the thing is that this is the input variables, input side, input layer. So this is inputted. Okay, so 65536. Okay, this one. Okay, so all these input nodes are there. Then they are connected with a hidden layer. Okay, much larger than that, then much larger than that, then okay, done. Then finally you have got 10 output nodes. Okay, so input layer, it is having 65536 nodes. They are all connected each other, fully interconnected. Okay, then again fully interconnected. Okay, then fully interconnected. So after that, it is coming to this last one, fully interconnected. Now suppose this for the first image, this 0 is having value as 0.75 and all are having total is 0.25. So 0 is winner for the first sample 1, image 1. Okay, image 2, 4th, uh, 4 has come as 9 has come as the winner. Okay, that is the highest probability. This is the image 2. Okay, like this it is going. So one image you are passing, then one image, another image you are passing, then another image you are passing. Okay, like this it is happening. I can give you a very good, very nice video. You can actually, if you want to see, it has actually described in a very nice way. Should I show?
Sir, please share that video. My question is only that confusion is that not go too many images. मैं single ही कोई image लेता हूँ, उसको sequence में add करने के बाद में उसको फिर वापस
No, वापस क्यों करेंगे?
reverse में करेंगे so that the once the image comes.
ना इमेज को मेरे को क्यों लाना क्यों है? Once processed, let it go, because I am already having my image repository with me. उसका भी तो नंबरिंग किया हुआ है ना, कि कौन सा सैंपल आप उठा के कौन सा टेस्ट कर रहे हैं, किसको टेस्ट कर रहे हैं, isn't it? अच्छा, let me show you the video, then I think it will be understanding, it will be much more clearer. Let me show you the video. Sure. Okay, I think here you can actually understand. I think here. Okay. So yeah, can you see this? Can you see the YouTube video?
Yes, sir.
Yes, sir.
But I think you will not be understand. You will not be getting the volume or the sound.
Yes, sir. No audio.
So voice you are getting?
No, sir.
Acha. ठीक है. Okay. At least I try to understand. Subtitle is given. Now see this one. So they are taking 28 by 28 pixels, 784. Okay, so that 784 are coming from the concatenating the columns. Okay, so the first image, the second image, that is 2. Okay, so now 2 is basically, this is the input layer. This is the input layer, and after that hidden layer, hidden layer, hidden layer. After that, this output layer there, it is having total 10 nodes. Now this second node, about the 0, 1, 2, third node, that is denoting 2, that is having the highest probability. That is having the highest probability. Okay, so in this way you are predicting. Is anybody speaking anything? So please, if you are having any doubt, please ask me. So for image recognition, convolutional neural network is the best one. Okay.
ऑफिस में अब रहेंगे तभी
You can do. So that's why I don't know whether you have experienced this thing very means that is becoming a very disturbing kind of thing nowadays, that whenever I am searching anything in Firefox, too many captchas are coming. Too many captchas are coming, and it's a kind of making my life hell. Totally. When sometimes you have to skip, then again some more captchas will be coming. Okay. So like that. Is it okay? Is it okay? Any Mr. Amar, are you still in doubt? Mr. Amar? Okay, so
We'll see.
sorry, that video. Yeah, you can. There is a lots of the huge repo of videos are there. That is, I'm sharing you the this. Acha, okay, I'm sharing you the video. Go to that user's profile. Okay, go to that user's profile. You'll be finding lots of videos there. In chat box, I'm giving. Okay.
Okay, sir. Okay.
So this is three blue, one brown, something like that name. Three blue, one brown, and they are expert in making this kind of very nice videos. And there are lots of videos on ML and DL. Okay, they are actually doing these things only, and very nicely, like tensors, like this concept of deep learning models and all these things. Very nicely they are displayed. See, pictorially, if you can do this, then it will be much more easier for you to understand instead of going for mathematics and all these things. So, some more codes I had prepared to share with you. So one is PyTorch based code. Okay. So for that, I have taken this California housing dataset. So California housing, basically, it is for predicting it is containing the data on median income of a particular household in California. Okay, and based on that, this is actually used for this getting rent in this California. Okay, some houses. So first we are bringing this particular, we are importing torch. Okay, so torch is for PyTorch. Then I am fetching the housing data, California housing. Okay, now I am keeping 1,000 data points for testing, then creating the data set. Then here is the how you are actually creating the model of this particular in PyTorch. What is the nature of um, creating what is the nature of that particular multi-layer perceptron model? Okay, so it will be starting with NN sequential. Sequential means that it will be step by step, means input to hidden to another hidden to another hidden. Like this, it will be going to up to this thing, up to the output layer. So first, you will be giving that linear layer. Okay, nn.linear means linear layer. You can find out here that exactly what does this mean. So linear input features is 8. I'm taking 8 features. Out features for that input layer is 16. That means it is the 16 number of nodes, 16 nodes in the first hidden layer. Bias true means the bias node whether you are keeping in the model or not. So it's your wish. Then activation function is taken as ReLU. Then again linear. Then 16 is the input features in the next layer, the first hidden layer, and output features is 8. Okay, bias is also true. Then ReLU, then linear again, and then input feature is 8, output feature is 1, and bias is true. And see here, we don't use any kind of activation function. So this is the last layer, that is the output layer. Now, what kind of loss function I am using? That is MAC, that is mean square error, MAC loss. Okay, and the optimizer I am using Adam. Okay, so Adam is a very popular kind of optimization principle. Adaptive momentum something. Yeah. So Adam is used as the optimizer. Learning rate is used as 0.01. Then I am basically converting the array data. Okay, that is NumPy array data into torch data. Okay, so I am converting it into torch. Otherwise, it will not work. Okay, then training. Training of that is the model architecture I am giving. What is the training data? What is the training data X train and Y train? Then what is the loss function and what is the optimizer? Then predicted train is basically the predicted you can say values of the observations from the data set. Okay, and you are passing it through the model. Then loss function you are calculating. Okay, then model zero grad means you are finding out the gradients and equating it to zero. Then loss, you are back propagating the error, that loss. Okay, and then you are repeating this. Sorry, you are actually using this particular optimizer. Okay, so this is the training step. Now, for 5,000 times you are running this. This is called as epoch. So what is epoch basically? That sometimes you are running that particular code. Sometimes you are intentionally stopping it somewhere and stopping it, and from there you are actually starting in the next iteration. Okay, so 5,000 epochs you are using. So see how the loss is coming down. It started with 4958. Now it is below 1. So 5,000 epoch. Okay, so finally it is so at 4900 it is 0.56. So sometimes what happens that epoch wise, sometimes it might create a higher error. Okay, then it should come down. So if it is not coming down, then there is some problem in that particular model. Okay, now you can use this dropout. Dropout means that some of the connections intentionally you are dropping. Suppose it is fully connected network, and take the case of this image processing, that is 720, 764, right? 28 by 20. So for that, 764 by 764 multiplied by around 1000. So that will be the number of networks, number of connections. So are those connections really needed? All the connections really needed? Okay, so you are intentionally dropping some. Okay, that means 10% of the connections you are dropping. Okay, so that is NN dropout. Okay, so this is model with dropout I'm having. So sometimes trying to basically fasten your computation. So here you can see that earlier it was starting with 4,000 something, but here it is starting with 2674, but it is actually moving slowly. You just see the speed how it is moving. It is slower than the earlier. Okay, and here the final loss is 0.65. Earlier it was 0.56. So this is not better than the earlier one. Okay, then next is with dropout I am evaluating. Then so here basically for a number of parameter combination, we can actually run the code and we can find out that who is giving you the best value. Okay, so in this way we can run. So this is using torch, right? Now now I am stopping it here. So if you are having any kind of question, you can ask. Then again I will be starting at 4:30, or I can start it little early also, 4:20 around. So the last 1 hour it will be devoted to that data visualization what Dr. Ayush started yesterday. So he'll be completing it today. And one apology for that we'll not be going to record that. We are not going to record that particular session, that 1 hour session. Okay, 4:30. Okay, no issues. I thought let us start early, then we'll finish it early also. Acha, so in the next session, I am planning to, yes.
Sir, should I stop the recording?
Yes, please stop it. Acha, I was planning to give this principal component analysis little bit understanding, and I'm not going into probabilistic one, but little bit understanding of this principal component analysis, and little bit talking about this dimensionality reduction, which is very important for you can say the machine learning